Alright guys, on to section 2.6. Now this is the final section of the chapter. Don't worry if you're still like very uncomfortable with what is going on, because we're going to take the next few days, work together, and we're just going to do proofs and do proofs and do proofs until you get a little bit more comfortable. You probably still won't be super comfortable, but you'll get more comfortable as the semester and as the year goes on. All right, so we're going to be introduced to two different kinds of proofs today. Now, the two-column proof is what we go to. So these two, we're going to like introduce it. This is what it is, but we're not really going to use it all that much. So the flowchart proof, it's more of a visual than just a proof, and we'll get to an example. What you need to know is that its content is mostly identical, or almost all identical. It should all be identical, but it's kind of hard, to that of a two-column proof. It's just written in a different form. And the same thing is true for the paragraph proof. It's written in complete sentences. Some of you may love that, some of you may hate that. And then it is also identical in content. So the same things on it, it's just showing it a different. All right, here is an example of a flowchart proof. Some of you may like these. I kind of find them really confusing sometimes. So we do have a word bank down here at the bottom, even though we really shouldn't need it, but it's there if you need it. All right, so AC equals AB plus AB. That's given, so we're just going to write given here. Okay, now notice this points to here, but this also points to there. So we need to do this before we can move ahead to this. Okay, AB plus BC equals AC. So where the heck did that come from? Well, AB plus BC equals AC. That's the segment addition postulate. Okay, now both of these errors are saying if we put these two together, how can we come to this? Well, notice, guys, this is congruent to AC and this is congruent to AC. So two things that are equal to the same thing, they are equal to each other. So we can then write this equals this. So that's what it is. So this is the transitive property of equality. And then from here to here, what do we do? Well, we subtracted AB from both sides of the equation. So that would be the subtraction property of equality. So that would be how a flowchart proof would go. All right, try this one on your own, and then we'll go over the answers. All right, let's look at this flowchart proof. So measure of angle 1 equals measure of angle 3, that is given. Okay, so notice there's an arrow that goes from here to here, and then an arrow that goes from here to here. So in order to tackle this, we have to do both of the ones before it. Okay, so measure of angle EBA is angle 2 plus angle 3. Okay, so the measure of angle EBA is 2 and 3. That is the angle addition postulate. We put two angles side by side together to equal the bigger angle. Okay, now anytime I said if something given is that two things are equal to each other, that should be a red flag that we are going to use substitution somewhere. Okay, so we have EBA equals 2 plus 3, and we're changing it to EBA equals 2 plus 1, and we're putting this and this together. So what we're going to do is we're going to substitute this 1 in for 3. Okay, so we're going to substitute measure of angle 1 in for this angle 3 to where I get this. So that is substitution. Okay, so from here over, we go EBA equals 2 plus 1 to EBA equals 1 plus 2. So all we did is we flipped the order that we added, which is the commutative property of addition. Now this is where I don't really like the flowchart proof, guys, because notice from here it goes down, but it also goes from here over. So we need both of these in order to do this last one here. All right, so let's go back to the diagram. Okay, measure of angle 1 plus measure of angle 2 is going to be the measure of angle CBD. That's the angle addition postulate. Okay, now notice angle EBA equals 1 plus 2 and angle CBD equals 1 plus 2, so they both are equal to the same thing. So if they're equal to the same thing, That means they have to be equal to each other by the transitive property of equality. All right, here's the last flowchart proof for a little while. Now, before we do that, let's introduce this theorem, and this seems kind of silly, but it's the right angles congruence theorem. And all the right angle congruence theorem tells us is that all right angles are congruent. I know that seems silly, but we do have a theorem that tells us all right angles are congruent. Now we're being very, very literal when it comes to proof, so we need very literal theorems, if you will. All right, so let's look. So it says AB, remember this is perpendicular to BC, and DC is perpendicular to BC. Okay, so ask yourself, what does it mean to be perpendicular? What is the definition of perpendicular lines? Well, the definition of perpendicular lines is that two lines that intersect to form a right angle. Okay, so if AB is here and BC are perpendicular, that means angle ABC is a right angle. And then also, if DC is perpendicular to BC, so DC is perpendicular to BC, that means that angle BCD is a right angle. Now, if they're both right angles, by the right angle congruence theorem, that means they have to be congruent. So right angle congruence theorem. All right, guys, here's another proof where we have to fill out both sides of the equation. So we're given that angle 1 and angle 2 are supplementary. And we're also given that angle 3 and angle 2 are supplementary. These two are given. Okay. Well, if they are supplementary, what does it mean to be supplementary? Hopefully you know by now that supplementary means that if you add them together, they equal 180. So this would be just the definition of supplementary. All right, now once again, we have angle 1 plus angle 2 equals 180, and angle 3 plus angle 2 equals 180. So if there's two things that are equal to the same thing, they have to be equal to each other. So that means angle 1 plus angle 2 has to equal angle 3 plus angle 2. So that would be the transitive property of equality. Now, notice I have this 2 on both sides. I could subtract an angle 2 from both sides. Subtraction. Property of equality. Anytime you subtract the same thing from both sides of the equation, that's the subtraction property of equality. And then when I simplify this, I get angle 1 equals angle 3, and that is simplify. All right, guys, do this one on your own. Now this one is almost identical to the one we did before. There's one added step at the end, but for the most part, they're almost identical. So try to go through this, do it, and then we'll go over it. All right, guys, hopefully you've done it on your own. Hopefully you've gotten through it. So angle 1 and angle 2 are complementary. Angle 3 and angle 4 are complementary. That's given. Okay, so well, what does it mean to be complementary? Well, that means you add them up, they equal 90 degrees. So that's just definition of complementary. Now, because they both equal 90 degrees, both angle 1 plus angle 2 and angle 3 plus angle 2 equals 90, because they are equal to the same thing, they equal each other, and that's the transitive part right here. Now notice the angle 2 on both sides, so we could subtract angle 2 on both sides, subtraction property of equality, and if we simplify, we get angle 1 equals angle 3. Now I'm guessing a lot of you stopped there. You have one extra step. We want to know that angle 1 is congruent to angle 3. So what we're going to do is we're going to put down here, angle 1 is congruent to angle 3. Guys, what does congruent mean? It means they're equal. So this is just definition of congruent. And now we are done. All right, so we just proved a couple theorems. We proved the congruent supplements theorem and the congruent complements theorem. So let's read through these. So the congruent supplements theorem tells us if two angles are supplementary to the same angle, then they are congruent. Okay, so if we're given that angle 1 is supplementary to angle 2, and angle 3 is also supplementary to number 2, then angle 1 has to be congruent to angle 3. Okay, so if two angles are supplementary with the same angle, then they are congruent to each other. All right, likewise down here, if two angles are complementary to the same angle, then they are congruent. So here, if we know that angle 4 is complementary to angle 5, and angle 6 is also complementary to angle 5, then angle 4 must be congruent to angle 6. Hopefully that makes sense to you guys. All right, let's look at a couple more theorems. Okay, so the linear pair postulate. And we've already discussed this before, now we just have a name for it. So the linear pair postulate tells us if two angles form a linear pair, then they are supplementary. Well, we learned this in section 1, or in chapter 1. Two angles that form a linear pair, yeah, they form a line, so they're supplementary. Okay, and then the vertical angles congruence theorem, this is going to be one of your best friends. Vertical angles are congruent, always. So that means angle 1 is always congruent to angle 3, and angle 2 is always congruent to angle 4.